Sirius 48 Romeo Charlie, cross Ventura at 6000, cleared VOR runway 25, approach at Oxnard.
Cross Ventura at 6,000, cleared VOR runway 25, approach at Oxnard for Sirius 8 Romeo Charlie. Okay, F is the flight plan altitude. So flight plan altitude is set to 6,000. For basic descents, VNAV is pretty simple, but this feature of the Garmin G1000 can be a bit finicky. Here are some of the techniques that we use to avoid the gotchas. So let's review some of the basics to make sure we are all on the same page. Let's look at the pieces of the VNAV profile. Let's say we're flying along at cruise altitude and we want to use VNAV to descend to a target altitude. That's called an active VNAV waypoint. The system creates a vertical path or vertical track for us to descend down. And that vertical track is defined by a flight path angle or FPA. Each aircraft has its own default FPA, but they're usually around 3 degrees. Now, where the vertical track intercepts your current altitude is called the top of descent, and the point at which the aircraft levels off is called the bottom of descent, or BOD. The G1000 can only create a vertical path within a range of acceptable FPAs. If the angle is too shallow, you will not descend fast enough for ATC. If it's too steep, you may overspeed the aircraft. Now, when the G1000 creates your vertical track, it first looks at your current position. If it is before the acceptable FPAs, it will create a vertical path with a top of descent. If you are within the range of acceptable FPAs, you will get an immediate descent. If you are beyond the range of acceptable FPAs, you will get no VNAV.
Now, the great thing about the G1000, Mossy, is that you can create a nice long vertical profile right in the flight plan. Now, I remember, though, when I first looked at it, I thought, whoa, that's complex. But I think once we tease it apart, you'll find it's not all that bad. It's really all about the VNAV waypoints, and these are defined by the blue altitudes in the flight plan. So in this example, we have a target altitude of 4,000 feet at Jurex and a target altitude of 3,300 at Okeze. Our active VNAV waypoint is 4,000 feet at Jurex. And note, though, that this is different from our active lateral waypoint at Suwana. We're going to fly direct Suwana and then to Jurex, all the while descending to reach Jurex at 4,000 feet using a flight path angle of 1.7 degrees. And our time to top of descent is about 2 minutes and 28 seconds. Now, the G1000 will also show us some altitudes in white for informational purposes. For example, our vertical path happens to cross Suwana at 4,700 feet, so that is shown in the flight plan using large white letters. Also, some altitudes from the database may be included for your reference. For example, the published altitude at the final approach fix is 2,800 feet. Just remember, blue is true. Those are the altitudes that define the vertical path, and white sheds light. Those are the altitudes provided for your reference only.
Now, I have a caution for you. VNAV can insert intermediate level-offs when you least expect it. Here we are descending on a vertical path, and the next waypoint is far enough away that we end up hitting the active VNAV waypoint before the acceptable FPAs for the next VNAV waypoint. So the G1000 will insert a bottom of descent and top of descent in order to create an acceptable vertical path to the next VNAV waypoint.
Yeah, but you gotta watch out. Those level-offs can really sneak up on you. You might be on this nice long arrival or approach with all the VNAV waypoints linking smoothly together, and when you least expect it, the G1000 sticks in an intermediate level-off. You really have to stay on top of the VNAV profile so you don't get surprised by a bottom of descent and possibly stall the aircraft because you neglect to add power.
I can't tell you how many students I've had get bit by this, and it's really dangerous when it happens in a jet. So pro tip number 1 is you need to monitor the time to the top of descent and bottom of descent to anticipate a change in power. So let's take a look at a typical VNAV descent, and let me show you the cues or milestones that I use to manage the power. As I approach the top of descent,
vertical track,
the G1000 is going to give me a 1-minute warning. Here, I'm going to put my hand on the throttle to remember that a power reduction is coming. When I reach the top of descent, I call out VPath green, and then I set the power for the descent. As I come up on the next waypoint, the only change might be a change in the flight path angle. So here I might need to just slightly adjust the power to maintain the proper airspeed. Now as I come up on the bottom of descent, I will get another 1-minute warning. This is where my threat level will go up because I do not want to cause a stall by forgetting to add power. Then, as the aircraft levels off, we get Alt V green, and as soon as I see this, I set my power, and finally we get Alt green as the G1000 enters altitude hold mode.